The air is thick with anticipation, the dawn casting a pale light over the runway, where one pilot prepares for a flight that will etch his name and his aircraft into the annals of history. The scene is set not just for a test flight, but for a reckoning that will redefine what machines and men can achieve together in the skies. This is the story of the P-51 Mustang, a fighter that began its life with promise, but would reach unforeseen heights through innovation, bravery, and relentless pursuit of speed. The year is 1942. World War II rages across continents and oceans. Amidst this chaos, engineers develop an aircraft that they hope will tilt the balance in the aerial war, the North American P-51 Mustang. Initially, the Mustang was powered by the Allison V1710 engine. Sleek and aerodynamic, it was fast, but not fast enough at high altitudes, where dogfights and bomber escort missions demanded superior performance. The Allison engine choked at altitude, limiting the Mustang's potential, and many doubted if it could truly dominate the skies. Then came a bold decision that would change everything. Replace the Allison with a British-designed Rolls-Royce Merlin engine, a masterpiece of engineering with a turbo supercharger that allowed it to breathe and roar at altitudes above 30,000 feet. But swapping engines was not just a matter of dropping one in and taking off. The Merlin was complex, powerful, and could only unleash its true fury with the right fuel, precision tuning, and a fearless pilot willing to push the envelope. Enter the test pilot, often seen as daring to the point of reckless. This pilot embarked on what many called a suicidal flight, deliberately pushing the P-51 Mustang beyond its tested limits, throwing caution to the wind in search of speed records that would defy common belief. His mission was to push the airplane to its maximum velocity, testing the durability of the engine, the aerodynamics of the frame, and the pilot's own nerve. This test flight was not just a numeric pursuit of miles per hour, it was a high-stakes gamble. The pilot knew that at speeds approaching 490 miles per hour, every component of the aircraft faced extreme stress. The risk of mechanical failure, engine detonation, or loss of control loomed large, yet the pilot's skill and the plane's cutting-edge design converged in a breathtaking display of speed and control. Central to the Mustang's achievement was a specially formulated aviation fuel, designed to withstand the pressures of the supercharged Merlin engine without causing knock, the destructive, uncontrolled explosions that could destroy an engine in seconds. This high-octane fuel was a silent partner in this flight, unlocking raw horsepower that the Mustang had never before achieved. At Wright Field in Ohio, engineers had painstakingly developed this fuel, combining chemistry and courage to ensure the Mustang could hit its peak performance without self-destruction. The roar of the engine during that flight was like a primal scream of power and precision, a sound echoing across the airfield and into history. As the Mustang shattered the 490 MPH barrier, the pilot's heart pounded, not just with fear but with a profound sense of accomplishment. He had flown not only the fastest piston-engine fighter in the world, but had set a new standard for aviation performance that would echo throughout the war. The test flight validated everything the engineers and designers had dreamed of and more. It proved the P-51 Mustang was no longer just a promising fighter. It was the pinnacle of piston-engine technology and aerial design. This flight gave the Allied forces a clear advantage, an aircraft that could escort bombers deep into enemy territory, outpace and outmaneuver enemy fighters, and survive in the toughest combat conditions. Beyond the raw numbers and technical achievements, this flight was about spirit, human resolve meeting machine innovation in a crucible of speed and danger. The success of this suicidal test flight catalyzed the Mustang's legendary status, transforming it into a symbol of hope, power, and technological supremacy that struck fear into the hearts of foes. Imagine the scene on the ground as the plane returned. Pilots, engineers, and spectators holding their breath, waiting for confirmation that the Mustang had survived and thrived. The testing pilots risked life and limb, but they were the unsung heroes behind every victory in the air. This chapter closes on the edge of the sky, leaving us perched between fear and triumph, ready to dive deeper into the Mustang's journey, from a prototype with potential to the unstoppable force that changed the course of the war. The skies above would never be the same again. The soaring triumph of the P-51 Mustang's 490 MPH flight was not a mere stroke of luck or pilot bravado. It was the outcome of extraordinary engineering precision, relentless innovation, and the indomitable will to build an unmatched flying machine. At the heart of this success story lies the Rolls-Royce Merlin engine, an intricate masterpiece of technology that transformed the Mustang from a promising fighter into the fastest piston engine aircraft of World War II. The story of the Merlin engine begins in the late 1930s, when Rolls-Royce embarked on a mission to create a high-performance power plant that would dominate the skies. Its design was revolutionary, a liquid-cooled V12 engine boasting a displacement of 27 liters, 12 cylinders arranged in a compact V, overhead camshafts, and 4 valves per cylinder. But what truly set the Merlin apart was its supercharger system. A two-stage, two-speed supercharger that allowed it to maintain horsepower even as aircraft climbed to dizzying altitudes where air became thin and less oxygen was available. This supercharger compressed the air entering the engine, providing a denser charge and allowing combustion at higher powers, even at altitudes above 30,000 feet. This feature was critical for the Mustang's role as a long-range escort fighter, ensuring it could keep up with bombers over Europe's vast war zones, maintain high speeds, and engage enemy fighters on equal terms or better. The engine's maximum output varied through its iterations, but could reach up to an astounding 1,490 horsepower in the most powerful versions installed in late-model Mustangs. However, marrying this formidable engine to the Mustang's airframe was a technical challenge. The Mustang's sleek design and lightweight frame had optimized aerodynamics for speed and range, but integrating an engine with a higher weight, different cooling needs, and more complex controls required careful engineering. Yet this union between frame and power plant proved seamless, a testament to the ingenuity of American and British engineers working side by side. Beyond raw power, the Merlin demanded a revolutionary fuel to unleash its full potential. Conventional aviation gasoline could not withstand the pressures and temperatures inside a supercharged engine. If the fuel detonated prematurely, a catastrophic event called knocking, it could cripple or destroy the engine within moments. To avoid this, the United States developed a specialized high-octane fuel blend, concocted at Wright Field, Ohio, that resisted premature detonation and allowed the Merlin to run safely at full throttle and maximum boost pressures. On the day of the historic test flight, this chemical wizardry met mechanical might. The pilot throttled forward, commanding the engine to deliver power at thresholds never before reached in production aircraft. The cockpit was a cacophony of engine hums, rattling instruments and rushing wind, while the temperature and pressure gauges danced at extremes that could spell disaster with a single malfunction. Every component, from the pistons racing within the cylinders to the cooling system, ensuring the engine did not overheat, was pushed to its limits. The coolant system had to be efficient enough to draw vast amounts of heat away, using a ram air cooling design that cleverly reduced drag while feeding cold air to the radiator. Engineers optimized the radiator design, even carefully shaping its inlet and outlet to minimize any penalty to aerodynamics, a vital factor when every mile per hour counted. The test pilot's hands were steady, but his senses heightened. Any loss of control, any hint of engine faltering at speeds approaching 490 mph could have ended the flight and his life. Instead, the Mustang roared like a living beast, slicing through the sky with lethal grace. The flight demonstrated the catastrophic speed that was once the stuff of dreams, now the tangible reality, roaring above the airfield. The plane's arrival back on the runway was met with a mixture of awe and relief. Engineers raced to assess the subject of their labor, eyes gleaming with pride as instruments confirmed that the engine and airframe had withstood the ultimate test. This was not mere experimentation. This was validation that the Mustang could dominate the unforgiving skies of World War II. The Mustang's vital statistics speak to the brilliance behind the machine. The Packard-built version of the Merlin, known as the V1657, delivered up to 1,290 horsepower and a top speed over 440 mph in combat-ready versions, with some variants reaching speeds close to 505 mph in optimal conditions. Its operational ceiling approached 42,000 feet, with a climbing rate of around 475 feet per minute, impressive numbers that made the Mustang a terror in dogfights and a reliable guardian on bomber escort missions. The fighter's armament, 650 caliber Browning machine guns, with thousands of rounds of ammo, combined with its speed and range, made it not only fast but deadly. Its internal fuel capacity, supplemented by external drop tanks, extended its range to over 2,000 miles, an unprecedented capability that allowed deep penetration into enemy territory. This technological masterpiece became a symbol of hope for Allied airmen, a fearsome opponent for the Axis powers, and an engineering marvel that blended power, precision, and endurance. The story of the P-51 Mustang and its Merlin engine is a story of collaboration between countries. Engineers, pilots, and the unforgiving physics of flight, all brought together by relentless innovation. In this dance of metal and fire, the engine was the heartbeat, the driving force that transformed a beautiful machine into a record-breaking legend. The test flight at 490 MPH was the moment when potential exploded into performance, when the dream of air superiority became a tangible, roaring reality that echoed through the skies and shaped the air war's outcome. As this chapter closes, the roar of the Merlin still rings in history, a reminder that behind every great aircraft is a story of human determination, scientific triumph, and the courage to fly beyond all limits. The P-51 Mustang, powered by the mighty Merlin, remains one of the greatest achievements in aviation, its legacy forever etched in the steel and sky where legends are born. The final chapter in the saga of the P-51 Mustang's incredible journey is a tribute to not just its raw speed or firepower, but to the seamless fusion of design, innovation, and human endeavor that turned it into one of the most iconic aircraft in history. With exactly 500 words to honor this masterpiece, this chapter dives deep into the technical marvels, the legacy it forged, and the enduring symbol it remains, even long after the roar of its Merlin engine echoes through history. First, consider the specifications that made the P-51 Mustang so extraordinary. At its heart was the Rolls-Royce Packard-built V1657 Merlin engine. This 12-cylinder liquid-cooled powerhouse generated 1,490 horsepower at war emergency power, a level of brute force that propelled the aircraft to top speeds of 437 miles per hour at 25,000 feet, a staggering figure for a piston engine fighter. Specialized variants such as the P-51’s pushed the upper envelope even further, reaching speeds up to 505 miles per hour. The engine's integration was a pinnacle of transatlantic engineering collaboration, blending British expertise and American production to redefine piston fighter capabilities. The Mustang's airframe was a study in aerodynamic efficiency and structural strength. Its 32 feet 2 inches length and 37 feet wingspan, paired with a height of 13 feet 8 inches, created a slender, sleek profile optimized for speed and maneuverability. The laminar flow wing, an innovation that minimized air resistance, significantly enhanced its range and velocity, enabling long-distance missions previously unattainable for fighter aircraft. Fuel capacity was revolutionary. Internally, the Mustang held 184 imperial gallons, supported by provisions for two 62.5-gallon external drop tanks. This gave it a combat radius exceeding 500 miles and a ferry range touching 2,000 miles, unmatched by most contemporaries, which allowed Mustang pilots to escort bombers deep into hostile airspace and return safely. Armor plating and pilot protections were integrated with care. The cockpit featured armored glass to shield aviators from enemy fire, combined with the famous bubble canopy introduced in later models like the P-51D, which afforded nearly 360-degree visibility. This enhanced situational awareness proved crucial during dogfights, where split-second decisions meant survival or death. The Mustang was heavily armed for its time. Equipped with 650 caliber Browning M2 machine guns, delivering a combined 75 rounds per second, it packed substantial firepower, capable of shredding enemy fighters or ground targets with lethal efficiency. Additionally, the plane could carry up to 2,000 pounds of bombs or 10 5-inch rockets, allowing it to serve multiple roles: interceptor, escort, and ground attack. Thermal and aerodynamic innovations abounded, The aircraft's Meredith effect radiator scoop cunningly converted engine heat into thrust, offsetting drag and contributing to greater top speeds. Coupled with efficient cooling systems, the Mustang's design allowed the high-output Merlin engine to operate safely at peak performance, a balance of intense heat management and aerodynamic finesse. Operational ceiling approached 42,000 feet, with climb rates of 3,475 feet per minute, a testament to its ability to quickly reach combat altitudes. It had a maximum takeoff weight, usually around 12,300 pounds, expertly balanced to maintain maneuverability despite heavy fuel and armament loads. The Mustang's reputation was also built on its pilot-friendly handling. Responsive controls, an ergonomic cockpit layout and synergistic systems reduced fatigue on long missions, contributing to the aircraft's reputation as pilots' favorite. Many veterans still speak of the Mustang's precise control, its forgiving nature in tight turns, and its capability to punish the enemy without compromising pilot safety. The P-51 Mustang's impact was profound and wide-ranging. Its design enabled the Allies to achieve air superiority, dramatically reduced bomber losses, and shifted the balance in the air war over Europe. The psychological impact on enemy pilots who feared the ace maker cannot be understated. It rewrote aerial combat tactics and set new standards for range, armament, and speed in fighter design. Its legacy extended beyond its wartime role. Post-war, the Mustang remained in service during the Korean War and influenced later fighter development. Even today, it is celebrated on airshow circuits, museum hangars, and in cultural memory as the embodiment of wartime innovation, determination, and technology at its zenith. In concluding this epic chronicle, the P-51 Mustang stands tall as a monument to human ingenuity, the perfect fusion of science, bravery, and industrial might. It transcended its role as mere machinery, becoming a symbol of hope, resilience, and the relentless pursuit of excellence in the face of adversity. The story of the P-51 Mustang is not just about an aircraft, but about the people who built it, flew it, and fought with it. It is about how innovation pushed the limits of what was possible, and how courage made the impossible a reality. This legend carved its name into the skies, forever a beacon of aeronautical triumph and human spirit. From a daring test flight that pushed the limits of speed and endurance, the P-51 Mustang's journey did not stop. It accelerated into full-scale production, becoming one of the most prolific and iconic fighters of World War II. This chapter reveals how the Mustang evolved from a groundbreaking prototype into a storied war machine produced in vast numbers, deeply influencing the course of the conflict and leaving a legacy that echoes through aviation history. The Mustang's production story is a testament to the monumental industrial effort mobilized by the United States during the war years. Total production reached an astounding 15,175 units, ranking it as the second most built American fighter after the P-47 Thunderbolt. The scale of its manufacture was staggering, reflecting the demand for a fighter that could do more than simply survive. It had to dominate. Originally commissioned by the British Purchasing Commission, the Mustang's initial batch of 320 aircraft rapidly expanded as its capabilities became undeniable. North American Aviation, headquartered in Dallas, Texas, was tasked with producing the lion's share of Mustangs. Their factories operated at fever pitch, churning out variants that included the P-51, P-51A, P-51B, P-51C, P-51D, and P-51K, the latter considered the most famous and widely used version. Each variant introduced incremental improvements, whether in engine power, armament, or cockpit design, showing a continuous evolution based on battlefield feedback and engineering advances. A crucial partner in the Mustang's massive production was the Packard Motor Car Company of Detroit, licensed to produce the Rolls-Royce Merlin engine under the Packard V1650 designation. Packard's assembly lines ensured the sophisticated engines that powered Mustangs met the rigorous standards required for combat excellence. This collaboration between aircraft manufacturing and automotive engineering united two American industrial giants in a synergy of speed, precision, and efficiency. The Mustang's production was not without obstacles. Early skepticism from the U.S. Army Air Corps Initially reluctant to adopt an aircraft designed for British needs, combined with the challenge of producing a complex fighter at scale while maintaining quality, placed enormous pressure on manufacturers. Yet overcoming these barriers was a part of the Mustang's story, one defined by determination to meet the soaring demands of aerial warfare. The P-51D variant, featuring a bubble canopy for improved pilot visibility, increased fuel capacity, and 650 caliber Browning machine guns, was the definitive Mustang in combat. It flew in every theater of the war, from the skies over Europe escorting bombers to the Pacific Islands' fierce dogfights and campaigns against German V-1 flying bombs. Its versatility was unmatched, and pilots revered it as both a reliable steed and a deadly predator. The Mustang's strategic impact extended far beyond the battlefield. It reshaped air combat doctrine by allowing long-range bomber escorts deep into enemy territory, drastically reducing bomber losses and enabling sustainable, relentless bombing campaigns. This shift decimated enemy industrial capabilities and crippled Axis Air Force's ability to defend their skies. Moreover, the Mustang served as a beacon of hope for the Allied airmen. Pilots entrusted this fighter with their lives, knowing it combined speed, range, firepower, and maneuverability in a single lethal package. The Mustang's prowess became a psychological weapon, daunting Axis pilots who nicknamed it with reverence and fear. Post-war, the Mustang's legacy continued. Many surviving aircraft were adapted for civilian use or transferred to Allied countries, extending their operational life well into the Cold War era. While newer jet fighters eventually eclipsed piston-engined planes, the Mustang remained a symbol of the engineering zenith and heroic valor of the W-2 generation. Today, the P-51 Mustang stands as a cultural and historical icon. Meticulously restored Mustangs thunder at air shows worldwide, their Merlin engines roaring a reminder of a time when technology and tenacity combined to shape the fate of nations. These warbirds captivate enthusiasts and historians alike, embodying the spirit of innovation and bravery that defined their era. Reflecting on its production, the Mustang's journey from a bold prototype to mass-produced warhorse illustrates more than manufacturing prowess. It tells a story of unmatched collaboration, relentless adaptation, and the pursuit of excellence under the harshest conditions imaginable. It is a story etched in the annals of aviation and war, immortalized by the countless pilots who took it to the skies and into history. As this chapter closes, it foregrounds the Mustang's transformation, a testament to the power of human ingenuity ramped to industrial scale, and the enduring spirit that turned metal, fire, and fuel into a weapon of victory. The beast unleashed was not just an airplane, but a turning point, soaring on the wings of innovation and courage toward an uncertain but hopeful horizon. The P-51 Mustang's ascent from a record-breaking test plane to battlefield legend was sealed in the skies over Europe, where its speed, firepower, and range drastically altered the air war's dynamics. This chapter delves deep into the Mustang's combat performance, revealing how it helped secure Allied air superiority and reshape the course of World War II. By late 1943 and into 1944, the P-51 had become the backbone of the U.S. 8th Air Force's long-range fighter escort. Prior to its arrival, Allied bombers such as the B-17 Flying Fortress and B-24 Liberator suffered devastating losses, exposed and vulnerable to the relentless attacks by German fighters. The Mustang's introduction changed that narrative, its ability to escort bombers all the way to their targets and back, maintaining top speeds near 440 miles per hour, gave the Allies a critical edge. The Mustang's agile performance allowed escort pilots to engage Luftwaffe fighters on equal or superior terms. The P-51 excelled in dogfights and was also highly effective at ground attack roles, carrying up to 2,000 pounds of bombs or 10 5-inch rockets. Its armament of 650 caliber Browning AN/M2 machine guns provided a lethal punch, delivering an astonishing 75 rounds per second per gun. This firepower decimated enemy fighters and ground targets alike, the 8th Air Force's fighter groups flying. Mustangs claimed nearly 5,000 enemy aircraft destroyed in aerial combat and over 4,100 destroyed on the ground by war's end. Among these groups, the 357th Fighter Group scored 565 victories, earning its reputation as one of the top-scoring squadrons. The 354th Fighter Group of the 9th Air Force was another standout, with 664 kills. Collective Mustang pilots achieved more kills than any other Allied fighter. Overwhelming Axis air power. Perhaps the most famous ace was Major George Earl Preddy Jr., whose kill count reached 2683, including 23 in the Mustang. Known for his skill and tenacity, Preddy embodied the deadly efficiency of the aircraft he flew. His death by friendly fire during the Battle of the Bulge in December 1944 was a harsh reminder of the war's brutal reality, but his legend, and that of the Mustang, lives on in histories and testimonies. Beyond its raw combat stats, the Mustang played a psychological role. Its presence forced German fighters into defensive postures, disrupting formations and tactics. It helped decimate the Luftwaffe's experienced pilots at a critical point in the war, when Germany was losing the ability to replace its losses. The Mustang's dominance contributed to the Allies gaining air superiority, which was essential for the success of the D-Day invasion and the subsequent ground campaigns across Europe. The Mustang's versatility was highlighted in other theaters, including the Mediterranean, North Africa, and the Pacific. In the latter, the aircraft escorted B-29 bombers targeting mainland Japan from airfields like Iwo Jima. Its long-range capability was crucial here, proving that the Mustang was not just a European fighter, but truly a global instrument of war. Despite the jet age dawn starting during W2's, the Mustang's robust design and performance kept it frontline well into the early 1950s, including service in the Korean War. However, by then, the era of piston-fired fighters was drawing to a close, replaced by faster jet-powered aircraft. Still, the Mustang's heroic record stood firm, influencing fighter design and pilot training for decades. Pilots who flew the Mustang often spoke of its easy handling, responsiveness, and lethal effectiveness. It was an aircraft designed not only to survive, but to dominate, providing the modern air warrior of its day a deadly tool balanced finely between speed, power, and resilience. In conclusion, the P-51 Mustang's combat history is one of decisive influence. It shifted the tides of air warfare by allowing the Allies to fight and win in the enemy's skies, escorting bombers, fostering pilot confidence, and breaking the back of the Axis air threat. It remains a symbol of technological excellence, coupled with human bravery, a legacy written in the adrenaline and steel of World War II's fiercest battles. To truly grasp the astonishing feat achieved during that suicidal test flight and the Mustang's battlefield dominance, one must dive deep into the technical specifications and innovations that made the P-51 not just fast, but a masterpiece of aeronautical engineering. This chapter unpacks the remarkable design features, performance parameters, and technological breakthroughs that set the P-51 apart in the crowded skies of World War II. At the heart of the Mustang lay its powerful engine, the Rolls-Royce Packard-built V1657 Merlin, a 12-cylinder liquid-cooled powerhouse producing up to 1,490 horsepower at war emergency power settings. This engine was a technological marvel, combining durability with extraordinary power-to-weight ratios that allowed the Mustang to reach top speeds of up to 437 miles per hour at 25,000 feet. Some specialized variants, like the P-51H, pushed this even further, achieving speeds up to 505 mph, edging ever closer to the dawn of the jet age. The airframe of the Mustang was sleek and purposeful, measuring about 32 feet 2 inches in length, with a wingspan of 37 feet, and standing nearly 13 feet 8 inches tall. It balanced aerodynamic efficiency with structural robustness. The laminar flow wing design reduced drag, a cutting-edge innovation that contributed significantly to the Mustang's long-range capabilities and blistering speed. Fuel capacity was another game-changer for the Mustang's operational range. Internally, it carried around 184 imperial gallons of fuel, but with the addition of two 62.5-gallon external drop tanks, the Mustang could achieve combat ranges exceeding 1,900 miles. This unprecedented endurance allowed Mustangs to escort Allied bombers deep into enemy territory, a pivotal factor in their protective effectiveness and air superiority. Armor protection was carefully integrated without compromising speed. The cockpit featured armored glass and plating to shield the pilot from enemy fire, while maintaining visibility and agility. Furthermore, the Mustang's controls were responsive and balanced, enabling pilots to perform tight maneuvers and rapid dogfight responses with precision, qualities often credited by veterans as life-saving in combat. Armament was formidable. 650 caliber Browning M2 machine guns, with a total ammunition capacity of around 1,880 rounds, guaranteed devastating firepower. This combination of rate of fire accuracy and fire volume allowed Mustang pilots to engage enemy fighters and ground targets with deadly efficiency. The aircraft could also carry up to 2,000 pounds of bombs or 10 5-inch rockets, augmenting its role in ground attack missions. The Mustang's cockpit evolved during production. The introduction of the bubble canopy in the P-51D variant was a major upgrade that eliminated blind spots, empowering veterans with 360-degree visibility and greatly enhancing situational awareness in dogfights. The cockpit layout was ergonomically refined to reduce pilot fatigue during long missions, another factor that contributed to the Mustang's widespread pilot acclaim. Cooling systems were innovatively designed to minimize drag while maximizing performance. The Mustang featured a unique radiator scoop under the fuselage, shaped and positioned to exploit the Meredith effect, a principle where heat energy from the coolant was converted into thrust, partially offsetting drag created by the radiator. This synergy between cooling and aerodynamics was a stroke of genius that boosted top speed without sacrificing engine safety. Service ceiling reached nearly 42,000 feet, allowing Mustangs to operate where many enemy fighters could not reach effectively. Climbing to 20,000 feet took approximately 7.3 minutes, demonstrating the plane's ability to rapidly reach combat altitudes crucial. For bomber escort and interception roles, the maximum takeoff weight for the P-51D model was about 12,300 pounds, a metric testament to its engineering balance, able to carry significant fuel and armament while maintaining high maneuverability and speed. This weight balance, along with advanced control surfaces, ensured pilots could respond to enemy tactics and threats with agility and confidence. On the maintenance front, the Mustang's design emphasized ease and reliability. The aircraft's modular engine and components allowed for quicker field repairs, a critical factor in sustained combat operations. Ground crews could perform necessary overhauls efficiently, ensuring that Mustang squadrons remained airworthy and ready with remarkable turnaround times. Drawing these innovations together, the powerful Merlin engine, aerodynamic efficiency, extended range, formidable weapons, and pilot-centered design, the P-51 Mustang was more than an aircraft. It was a technological symphony, a fusion of cutting-edge science and practical warfighting needs that projected unprecedented power and versatility from a single machine. In the end, the Mustang's specifications were not just numbers. They represented the very edge of piston-engine fighter performance, a machine that blended speed, firepower, range, and agility into an unparalleled package. These attributes ensured it not only shattered records, but also shattered enemy resoluteness, forever altering the skies above war-torn Europe and beyond. As this chapter closes, it leaves readers not just marveling at impressive figures, but appreciating the relentless innovation, meticulous design and resourceful engineering that made the P-51 Mustang the definitive symbol of aerial superiority in World War II. Its legacy endures as a testament to human ingenuity's power to transform metal and fuel into legends that flew faster, farther, and fiercer than any before. The P-51 Mustang reached beyond being just a warplane. It became a symbol, a marvel of innovation, and an enduring legend. As the war drew to a close, its technological and tactical breakthroughs set new standards in aviation. This chapter explores the innovations that made the Mustang a game-changer, the lasting legacy it imprinted on air combat, and the echoes of its roar that still resonate decades after its maiden flight. At the core of the Mustang's innovation was its laminar flow wing, a design pioneered by North American aviation's engineers to reduce aerodynamic drag more effectively than traditional wings. This streamlined design minimized air resistance, allowing the aircraft to slice through the sky with unparalleled efficiency, contributing greatly to its unmatched speed and long range. The wing's technology was so ahead of its time that it influenced fighter designs for decades, laying a blueprint for future high-speed aircraft. The integration of the Rolls-Royce Merlin engine, enhanced by American manufacturing expertise as the Packard P-51’s, was more than a casual upgrade. It redefined piston fighter potential. The two-stage, two-speed supercharger enabled the Mustang to sustain power at high altitudes, where decisive battles were fought, effectively eliminating earlier altitude performance limitations. This integration was a milestone in transatlantic technological collaboration during the war, synergizing British engine excellence with American airframe innovation. Another pioneering feature was the innovative cooling system, featuring a radiator scoop cleverly designed to exploit the Meredith effect. This phenomenon, where the heat extracted from the engine was converted into jet thrust, turned a potential drag source into an aerodynamic advantage. This system enhanced speed and efficiency, embodying a rare moment when thermodynamics and aerodynamics came together to breathe additional life into conventional piston engine technology. The P-51's role as a long-range escort fighter revolutionized strategic bombing campaigns. Previously, bomber formations operated with limited or no fighter cover deep into enemy territory, leading to huge losses. The Mustang changed this dynamic, enabling fighter cover to accompany bombers all the way to their targets and safely bring them home, drastically reducing attrition rates. This tactical shift was pivotal in degrading Axis industrial power and morale. The aircraft's exceptional firepower also broadened its operational scope. Besides aerial combat, Mustangs performed strafing runs, ground attacks, and anti-shipping missions with unmatched efficiency. This multi-role capability allowed commanders to deploy the Mustang flexibly, responding to the fluid demands of a dynamic battlefield. Its impact on pilot tactics and morale was profound. Pilots loved the Mustang's responsive controls, visibility improvements, especially with the bubble canopy, and its reliability under fire. The plane instilled confidence, allowing aviators to engage aggressively, a psychological edge that carried into combat success. Despite its wartime dominance, the Mustang's story didn't end with WO2. Its design influenced post-war aviation developments and served in conflicts such as the Korean War before being phased out by jet aircraft. Yet it continues to captivate aviation enthusiasts, historians, and engineers. Its sleek lines and thunderous Merlin engine roars at air shows symbolize a golden age of aviation innovation and valor. Today, restored Mustangs grace museums and airfields worldwide. Their flying exhibitions a vivid, roaring tribute to a warplane that combined art, science, and courage. The legacy it forged is not merely technical or tactical. It is a testament to what humanity can achieve when innovation meets necessity and daring. The P-51 Mustang remains more than a machine. It is a story etched in sky and steel, a legend carried forward by those who treasure the spirit of flight and the courageous hearts that soared into history aboard its wings. The final chapter in the saga of the P-51 Mustang's incredible journey is a tribute to not just its raw speed or firepower, but to the seamless fusion of design, innovation, and human endeavor that turned it into one of the most iconic aircraft in history. With exactly 500 words to honor this masterpiece, this chapter dives deep into the technical marvels, the legacy it forged, and the enduring symbol it remains, even long after the roar of its Merlin engine echoes through history. First, consider the specifications that made the P-51 Mustang so extraordinary. At its heart was the Rolls-Royce Packard-built V1657 Merlin engine. This 12-cylinder liquid-cooled powerhouse generated 1,490 horsepower at war emergency power, a level of brute force that propelled the aircraft to top speeds of 437 miles per hour at 25,000 feet, a staggering figure for a piston engine fighter. Specialized variants such as the P-51’s pushed the upper envelope even further, reaching speeds up to 505 miles per hour. The engine's integration was a pinnacle of transatlantic engineering collaboration, blending British expertise and American production to redefine piston fighter capabilities. The Mustang's airframe was a study in aerodynamic efficiency and structural strength. Its 32 feet 2 inches length and 37 feet wingspan paired with a height of 13 feet 8 inches, created a slender, sleek profile optimized for speed and maneuverability. The laminar flow wing, an innovation that minimized air resistance, significantly enhanced its range and velocity, enabling long-distance missions previously unattainable for fighter aircraft. Fuel capacity was revolutionary. Internally, the Mustang held 184 imperial gallons, supported by provisions for two 62.5-gallon external drop tanks. This gave it a combat radius exceeding 500 miles and a ferry range touching 2,000 miles, unmatched by most contemporaries, which allowed Mustang pilots to escort bombers deep into hostile airspace and return safely. Armor plating and pilot protections were integrated with care. The cockpit featured armored glass to shield aviators from enemy fire, combined with the famous bubble canopy introduced in later models like the P-51’s, which afforded nearly 360-degree visibility. This enhanced situational awareness proved crucial during dogfights, where split-second decisions meant survival or death. The Mustang was heavily armed for its time. Equipped with 650 caliber Browning M2 machine guns, delivering a combined 75 rounds per second, it packed substantial firepower, capable of shredding enemy fighters or ground targets with lethal efficiency. Additionally, the plane could carry up to 2,000 pounds of bombs or 10 5-inch rockets, allowing it to serve multiple roles: interceptor, escort, and ground attack. Thermal and aerodynamic innovations abounded. The aircraft's Meredith effect radiator scoop cunningly converted engine heat into thrust, offsetting drag and contributing to greater top speeds. Coupled with efficient cooling systems, the Mustang's design allowed the high-output Merlin engine to operate safely at peak performance, a balance of intense heat management and aerodynamic finesse. Operational ceiling approached 42,000 feet, with climb rates of 3,475 feet per minute, a testament to its ability to quickly reach combat altitudes. It had a maximum takeoff weight, usually around 12,300 pounds, expertly balanced to maintain maneuverability despite heavy fuel and armament loads. The Mustang's reputation was also built on its pilot-friendly handling. Responsive controls, an ergonomic cockpit layout, and synergistic systems reduced fatigue on long missions, contributing to the aircraft's reputation as pilots' favorite. Many veterans still speak of the Mustang's precise control, its forgiving nature in tight turns, and its capability to punish the enemy without compromising pilot safety. The P-51 Mustang's impact was profound and wide-ranging. Its design enabled the Allies to achieve air superiority, dramatically reduced bomber losses, and shifted the balance in the air war over Europe. The psychological impact on enemy pilots who feared the ace-maker cannot be understated. It rewrote aerial combat tactics and set new standards for range, armament, and speed in fighter design. Its legacy extended beyond its wartime role. Post-war, the Mustang remained in service during the Korean War and influenced later fighter development. Even today, it is celebrated on airshow circuits, museum hangars, and in cultural memory as the embodiment of wartime innovation, determination, and technology at its zenith. In concluding this epic chronicle, the P-51 Mustang stands tall as a monument to human ingenuity, the perfect fusion of science, bravery, and industrial might. It transcended its role as mere machinery, becoming a symbol of hope, resilience, and the relentless pursuit of excellence in the face of adversity. The story of the P-51 Mustang is not just about an aircraft, but about the people who built it, flew it, and fought with it. It is about how innovation pushed the limits of what was possible, and how courage made the impossible a reality. This legend carved its name into the skies, forever a beacon of aeronautical triumph and human spirit. If you've stood with us through the thunder of history, you know there's always more beneath the surface. Hit subscribe now and ring the bell, because every story of war, courage, and consequence deserves to be told. Join our ranks, dive deep into the untold battles, and become part of the mission to remember. Your next chapter starts here.